Hello students, in previous lecture we have studied about the properties of parallelogram, rectangle and square and the examples which is based on those properties we have solved from practice set 5.1 and 5.2. Today we are going to study about the properties of rhombus. Then see here, first of all, rhombus. Rhombus, that means it is a quadrilateral which having all sides with equal length. That means here length of all sides of quadrilateral is equal. That means length AB is equals to length BC is equals to length DC is equals to length AD. That means here it is a quadrilateral in which all four sides are congruent. Sides are congruent and their lengths are equal. That means here AB congruent BC, congruent CD, congruent AD. And here we can represent that rhombus ABCD in which all four sides are congruent. Then we can write the properties of rhombus. Then see here the first property, that is all four sides of rhombus are congruent. Then one more property, that is see here the opposite angles of rhombus are congruent. That means here opposite angles of rhombus are congruent. That means angle ADC congruent angle ABC as well as angle BAD congruent angle DCB. Then one more property I am going to discuss with you of rhombus, that is diagonals of rhombus are perpendicular bisector of each other. That means here BD perpendicular to AC, and as they are bisector of each other, therefore BD is a bisector of AC. Therefore here OA congruent OC, as well as here AC is a bisector of BD. Therefore here OB congruent OD. That means see here, if the length of that side AB of that rhombus is 5 cm, then BC is of 5 cm, CD is of 5 cm and AD is of 5 cm. And here if the diagonal AC is of 20 cm, then OA is of 10 cm and OC is of 10 cm. And here if BD is of 25 cm, then OD is of 12.5 cm and OB is also of 12.5 centimeter. That means diagonals are bisector of each other, as well as diagonals of rhombus are perpendicular to each other. That means angle AOD is of 90 degree, as well as angle AOB, angle BOC and angle DOC are of 90 degree. Then that is about the few properties which is related with that rhombus. Then one of the property which is related with that rhombus we have to prove here, that is the diagonals of rhombus are perpendicular as well as bisector of each other. This property we have to prove here, that is diagonals of rhombus are perpendicular bisector of each other, figure or diagram which we have to draw here. That is here, see here, the rhombus EFGH which is given here, in which that is EF congruent, GF congruent, HG congruent, EH. That means quadrilateral EFGH is a rhombus. Then here we have to draw the diagonals of that rhombus to prove this property. See here, we can draw the diagonals, that is EG and HF are the diagonals of rhombus, but we have to prove that those diagonals are bisector of each other, as well as diagonal EG perpendicular to diagonal HF. Diagonal EG and diagonal HF intersect at a point O. Then we have to write the given concept here first. Then see here, diagonals of rhombus are, that is the part which is given here. Then the diagonals of rhombus are perpendicular and bisector of each other. That part we have to prove here. Therefore, we have to write the given part first here in the given. Therefore, see here, quadrilateral ABCD is a rhombus. It is a rhombus. That means here, as ABCD is rhombus, therefore we can write the property of that rhombus, that is EF congruent, GF congruent, HG congruent, that is EH. That means all sides of rhombus are congruent. Then here, diagonal EG intersect diagonal HF at point O. Then see here, we have to prove that EG is perpendicular to HF. Therefore, we have to write this in to prove that. Then see here, EG perpendicular to HF. We have to prove this property. as well as here EG is a bisector of HF. That means here we have to prove that OH congruent OF. That we have to prove that. That is diagonal EG is a bisector of diagonal HF. That means here OH congruent OF. We have to prove this also, as well as here the diagonal HF is a bisector of EG, diagonal EG. We have to prove that OE congruent OG. OE congruent OG. Then we have to prove those all properties here. Then on the basis of the properties which we have already known, on the basis of those properties we have to prove this theorem or property of rhombus. Then here proof which is given here. See here, quadrilateral ABCD is a rhombus. Here EF congruent EH. EF congruent EH. Then see here, as EF and EH are congruent, then we have already studied about that points which are present at equidistance from the segment, that is from the endpoints of the segment, that are on the perpendicular bisector of that segment. That is, see here, HF is a segment of which point H and point F are the endpoints, and here as EH and EF are congruent, that means here E is a point which is at equidistance, that means at equal distance from endpoint of HF, and here the point which is equidistance from the endpoint of segment, that is always present on perpendicular bisector of that segment. As EF congruent EH, therefore point E is at equidistance from point H and point F. Therefore here point E is on the perpendicular bisector of segment HF. That means here, let this equation number 1. Similarly, here HG congruent FG, that is HG congruent FG. Therefore G is a point which is at equidistance from the same endpoints of the same segment, that is from H and from F. That means point G is also present on perpendicular bisector of HF. That means as HG perpendicular to FG, according to this property, we can write that here point G is present on perpendicular bisector of segment HF. Let this equation number 2. Then see here, from equation number 1 and 2, from equation 1 and 2, that is here point that E and G are present on perpendicular bisector of HF. That means here EG is perpendicular to HF. That means we can write that EG perpendicular to HF, as well as EG is a bisector of HF. Therefore here OH congruent OF. Similarly, we can prove that HF is a perpendicular bisector of EG. Similarly, here we can prove that OE congruent OG. That means point H and point F are present on the perpendicular bisector of that EG. Therefore, OE congruent OG. That means that is the proof of all properties which we have to prove here. Then see here, we will solve few examples which is based on properties of rhombus, which is given in the practice set 5.3. Example which is given in question number 2, that is quadrilateral PQRS is a rhombus. See here, quadrilateral PQRS is a rhombus. That means here we have to write that quadrilateral PQRS is a rhombus. That given property from which we can write the few concepts which is related with that rhombus, that is PQ congruent QR, congruent side SR, congruent side PS, and here PQ which is given of 7.5 cm, but all sides of rhombus are congruent. Therefore, QR is of 7.5 cm. That means here PQ is equals to QR is equals to SR is equals to PS is equals to 7.5 cm. That means here QR is of 7.5 cm. Then we have to find out the angle PQR as well as angle SRQ, and here the angle QPS is of given, that is of 75 degree. Then the property of rhombus which we have to use here, that is opposite angles of rhombus are congruent. Therefore here angle QPS is equals to angle, that is SRQ, angle SRQ. But here angle QPS which is given of 7.5 degree. Therefore, here angle SRQ is of also 75 degree. Then see here that angle is also of 75 degree. Then see here the remaining angle, that is angle PSR as well as angle RQP we have to find out. See here, as well as angle RSP is equals to angle PQR. Angle PQR, that is the opposite angles of rhombus. Angles of rhombus. Let the measurement of those angles be, that is of x degree. We can find out the measurement of those angles using property of, that is quadrilateral, that is sum of measure of all angles of quadrilateral is 360 degree. That means angle P plus angle Q plus angle R plus angle S is equals to 360 degree. Therefore, here angle P, which is given here 75 degree, plus angle Q, which is given here, that is x degree, angle S is also of x degree, and angle R is of 75 degree, is equals to 360 degree. Therefore, here 2x plus 75 plus 75, that is 150, is equals to 360 degree. Therefore, here 2x is equals to 360 minus 150, that is of here 210. Here x is equals to 210 upon 2, that is 105 degree. And here the angle PSR and angle PQR is equals to x degree. Therefore, putting the value of x, that is angle RSP is equals to angle PQR is of 105 degree. That is about the few examples which is given in the practice set 5.3. Then we will solve one more example which is given in the practice set 5.3, that is, see here, quadrilateral ABCD, which is given here, is a rhombus. See here, quadrilateral ABCD is a rhombus in which the diagonals AC and diagonal BD, which intersect at point O, and here AC is a diagonal which is given of 20 centimeter, as well as here BD is one more diagonal of rhombus which is given here, that is 21 centimeter. Then we have to find out the side of rhombus, that is ABCD. Rhombus ABCD. That means we have to find out AB, BC, CD or AD. Then see here, using the properties of rhombus, we can find out the length of side of rhombus from the given length of, that is diagonals of rhombus. Then see here, quadrilateral ABCD is a rhombus. It is a rhombus. Therefore, we can write that AB congruent, BC congruent, CD congruent, AD, which we have to find out the length of those sides of that given rhombus. Then here AC, which is a diagonal, is of 20 centimeter, which is given here. AC is 20 centimeter and BD is of 21 centimeter. But we know that diagonals of rhombus are perpendicular bisector of each other. Therefore, here we can write that OA congruent OC, OA congruent OC. But here AC is given, AC is equals to OA plus OC, but here OA and OC are congruent. Therefore, here putting the value of AC, that is 20 centimeter, is equals to OA and OC are congruent. Therefore, OA plus OA. Therefore, here OA is equals to 10 centimeter as well as OC is equals to 10 centimeter. Then see here, OA is of 10 centimeter as well as OC is of 10 centimeter. And here BD, which is given here, that is of 21 centimeter, but here OD congruent OB, OD congruent OB according to this property, that is diagonals of rhombus are perpendicular bisector of each other, OD congruent OB. But here BD, which is given of 21 centimeter, and BD is equals to OD plus OB, and therefore here 21 OD plus centimeter, that value is putting here. Therefore OD plus OD, therefore OD is of, that is 10.5 centimeter, as well as here OB is of 10.5 centimeter. But here according to this property we can write that AC perpendicular to BD, therefore angle AOB is of 90 degree. Then see here, or focus on any one of the triangle, that is here triangle AOB. In triangle AOB, here angle AOB is of 90 degree. Therefore triangle AOB is right angle triangle, and here see here that angle which is of 90 degree, and therefore AB is a hypotenuse. AB is a hypotenuse, and therefore according to Pythagoras theorem we can write that here OA square plus OB square is equals to AB square. And here we have to find out AB. Therefore, putting the value of OA which is here of 10 centimeter, that is 10 square, plus here OB is of 10.5 centimeter, that is 10.5, that is square, is equals to AB square. And here 10 square, that is 100, plus here 10.5 square, that means here 110.25 is equals to AB square. And here therefore AB square is equals to 210.25. Therefore AB is equals to, see here, taking square root on both sides, and therefore the 210.25, the square root of this is 14.5 centimeter. That means here AB, which is the side of that rhombus, which is of 14.5 centimeter. That means here AB is equals to BC is equals to CD is equals to AD is of 14.5 centimeter. And therefore here we can find out the perimeter of that rhombus, that is here 14.5 plus 14.5 plus 14.5 plus 14.5, that is here 58 centimeter. That means we can also find out the perimeter of that rhombus, that is about the properties of rhombus as well as the examples which is based on that properties of rhombus. Then in next lecture we will study about the trapezium and their properties as well as the examples which is based on trapezium or properties of trapezium. Thank you.